We heavily rely on our phones, service, GPS, and weather forecasts all the time. They all have one thing in common. They're all powered by satellites. Though we often overlook the lasting marks that satellites have on our Earth orbit, a finite resource being overexploited by satellite missions, we live in a world where, due to the overwhelming presence of space debris, we risk the possibility of unable to send satellites or spacecraft into space in the future. We must tread carefully to avoid this risk. Enter Laser Orbital Debris Removal, LODR, a type of ground-based laser. A powerful laser will be positioned on the ground and aimed at debris, gradually slowing it down until it falls and burns up in the Earth's atmosphere. In short, it is a laser beam powered by a propulsion system, or a system broom, that vaporizes the surface of debris, compliant with Institute observations of small space debris in low Earth orbit by means of a CubeSat.
CubeSats, or small sats, are used in space debris removal, but they are not particularly prevalent in the realm of laser orbital debris removal. Traditionally, a CubeSat is deployed from a mothership, which hunts down space debris, stabilizes its altitude, and drags it to a lower orbit. It's highly efficient to let the CubeSat do all the dirty work. Ablation is a new trend in remediating space debris. It works by striking a laser on the surface for nanoseconds, ejecting hot plasma, and thus generating thrust. LODR takes into account an optimized, cost-effective solution. This is done by engaging the laser, such that the target is slowed by up to 200 meters per second to drop its perigee to 200 km, which facilitates rapid re-entry. After the CubeSat is launched, the ground-based laser uses data from the CubeSat, as it detects the proximity of space debris with regards to the laser. This method of reducing the position uncertainty of space debris, also known as acquisition, improves upon the previous method of using telescopes, which is costly to maintain and less efficient than LODR. Space missions are notorious for how expensive they are. Research estimates that small objects can be removed at a cost of a few $1,000s per object. A lower estimate shows that the cost for long-term schemes is lowered to $300 per object. Combined with $150K for the construction of a 3U CubeSat, from which the 3U size is inspired from another cleanup CubeSat called Oscar, 3 minutes to lower to the perigee to 200 km, and approximately 10 minutes taken from detection to removal, LODR is both efficient in cost and time.
Laser ablation requires very powerful laser beams and very high precision. Ablation releases hot gas, allowing the small components of space debris to stay in the orbit of Earth temporarily, and get slowed down and loses the centripetal energy once they experience the atmosphere drag when they encounter the denser layer of the Earth's atmosphere. The main concern with the traditional ground-based laser is that of accuracy. The use of CubeSat increases accuracy and holds the power to simultaneously detect many pieces of debris using Institute methods. Not only that, but ground-based lasers generate much more power than space-based lasers, and are environmentally friendly as plasma poses no harm to the environment. Despite its cost benefits, unfortunately, there are limitations and potential drawbacks from the method, especially concerns regarding safety. In reality, thousands of satellites and spacecraft are currently orbiting and working in the Earth's orbit. Accidentally hitting these working components is more likely to cause significant consequences both economically and socially. However, this is a risk that we are willing to take in order to make the world a better place.
The Earth is what we all have in common.
Like how environmental protection is crucial on Earth, the preservation of Earth's orbit is equally as important as we continue to explore this vast world we can't see.
Laser orbital debris removal, equipped with cutting-edge CubeSat technology, is
The way
to go.